Today we are going to discuss some special cases of projectile motion. We'll take the motion of a projectile which is projected from certain height in horizontal direction. What will be the time of flight? What will be its equation of trajectory? What will be the range there? What is the velocity at any particular instant? After that, we'll discuss some of the conceptual type questions on projectile motion and some special cases there, especially the way the questions are asked on that, and you are asked to prove certain things there in projectile motion. We'll also discuss that how there are two angles of projection for a given velocity of projectile for same horizontal range. How we derive that one, and what are the implications there, and what type the questions can be asked on that. We'll also discuss a case where we'll show that for a given height, a projectile is at two different instants in its motion there, and what is the sum of these two times represents. So if you take the sum of these two times, this will give you a special value of the time related with the projectile motion. What is that? We'll discuss it all in today's discussion. Let's now take a case when a body is thrown horizontally from certain height. Suppose this represents height h, from where we are throwing a body horizontally with a velocity say v. So it will move, it will follow a projectile path, it will strike at the point A on the ground level. So suppose this is the horizontal direction where it is striking there, and this is the horizontal reference level there. So here, suppose we want to find time of flight. Remember, the body is thrown from certain height in horizontal direction. So obviously there is, from there it is not rising further. So obviously there is no question of any time of ascent there. It is already at the maximum height. So from there it is now falling downward. So it will now have only time of descent, you can say, and that will be equal to the time of flight here. So if you consider now time of flight for this case, time of flight. So this time of flight, suppose I represent by t. So what you will get here? Vertical displacement described is h. Initial vertical velocity, if it is thrown horizontally, so initial vertical velocity, this will be 0. So if you consider, then it is your 0 plus half gt square, because we are using s equals to ut plus half at square, you can think. So this u term, which is your initial vertical velocity, that is 0. So t will be equals to 2h by g square root. This is the expression for time of flight. If you now consider horizontal range, this is the horizontal range. So the horizontal range, if you consider horizontal range r, this will be equals to, r will be equals to horizontal velocity multiplied by time of flight. Now, body is thrown in the horizontal direction with velocity v. So this velocity will remain v, and this is the time of flight. So it is your 2h by g square root. So this is the expression for the horizontal range. Suppose you want to find velocity at any instant. So if you want to find velocity at any instant, say t. Remember, it's a horizontal velocity. Suppose I represent it as your vh, which is the horizontal velocity. This will remain v because it is thrown with velocity v, it is not going to change. Vertical velocity, vv. This is the vertical velocity at time t. This will be equals to g into t, because initial vertical velocity was 0. So in that case, it is just gt. Therefore, net velocity or resultant velocity at any instant t, that we are representing by capital V. This will be a square root of VH square plus VV square. Like here, you can assume it has a horizontal velocity V, VH is this direction, VV is in this direction, and its resultant will be somewhere in this direction, that is your capital V. And if I assume that it is at an angle theta, we can find the expression for that also. So this term will be equals to a square root of V square plus GT whole square. This will be the resultant velocity magnitude. If you want to find out the angle made by this one, so tan theta will be equals to V vertical by V horizontal. So it is your GT by V. And that implies that theta equals to tan inverse GT by V. This is the expression for the angle made by the resultant velocity with the horizontal direction. Let's now take equation of its trajectory for this particular case. Again, let's assume that let x be horizontal displacement and y be vertical displacement in time t. So what we can write for x, this will be equal to v into t, because the horizontal velocity is v, time is t, so we can get this one. So this t will be your x by v. Suppose I call it as equation 1. And for y, which is the vertical displacement, so here y will be equals to half gt square, because the initial vertical velocity will be 0. So first term will be 0 and it is only half gt square. So putting for t, if you consider y will be your half g x by v whole square, and that is your y equals to half g x square by v square. So again, this is the equation of a parabola, because it is the equation of the trajectory, basically equation of trajectory, and again it is in the form of parabola equation. And again it is in the form of equation of a parabola, y equals to 4ax square. So in that case, this will also have again the path which will be parabolic. So this is the equation of parabola. Therefore, path will be parabolic. So again, we get the path of the projectile as a parabolic one. For this case also, we have obtained the expression for horizontal range for a body projected obliquely as r equals to v square sine 2 theta by g. This is the expression for the horizontal range. Now you can see that this depends upon the velocity and also on the angle of projection. So from this we can say that range is depending upon the angle of projection, and as the angle of, and with increase of angle, sine theta increases, in that case the range should also increase. So if you consider suppose 10 degree angle of projection and 20 degree angle of projection for a given velocity of projection, so the range will be more there for 20 degree, because in that case it will be your sine 2 into 10 in one case, in other case it is sine 2 into 20. So obviously at 20 degree its range will be more. Similarly, if you consider 20 degree and 30 degree, then 30 degree will have more value. So that way, initially you will find that it depends upon the angle like that, and you can find out the relation there, which one will have more range. But here you see one thing. It is said that for a given velocity of projection, there are two angles of projection for same horizontal range. So let's see how we get that. Here, range is your v square by g into sine 2 theta. So we can write it as your v square by g sine pi minus 2 theta, because sine 180 minus theta is also your sine theta. This can be written as your v square by g, and suppose I take 2 outside, then it is your pi by 2 minus theta. And for this 90 minus theta, if I use phi, where phi is pi by 2 minus theta. Remember, it is the same range value r we have used. We have just modified the equation. So what you get, range value which is r for a given angle of projection theta for a particular velocity. Same range we get when the angle is phi, and of course the velocity is same. So that means for a given velocity of projection v, range is same for two different angles, theta as well as phi. And how the two are related? It is your phi equals to pi by 2 minus theta. That means you can also write theta plus phi. This is your pi by 2. That means these two angles are complementary angles. So there are two angles of projection for a given velocity of projection for same horizontal range, and these two angles are complementary. Like suppose if you have a body which is thrown with a particular velocity at 30 degree, whatever range you get there, at its complementary angle, that is 60 degree, again the range will be same. Similarly, for 20 degree and 70 degree, the range will be same. For 10 degree and 80 degree, the range will be same. So if you get any particular problem there, where you have been given that a body is projected with this particular velocity at this particular angle, what will be angle of projection which gives the same horizontal range as given by this case? And they have given you 4 options. So you need not simplify that. As long as the velocity value is given to be same, you just find out for the given angle of projection in the problem, which is its complementary angle. Choose for that option, that will be the answer. There is another conceptual type question you will often come across, where it is said that the angles which is less than 45 degree, at the same angle more than 45 degree, you will have the same horizontal range for a given velocity of projection. That means you are throwing a body at a particular velocity for an angle of projection which is 45 minus theta. That means it is theta less than 45. Whatever range you are getting, you will get the same range when you are increasing the angle by the same amount from 45 degree. That means at 45 plus theta also, you will have the same angle or same horizontal range. Let's see how we get that. Suppose we have the range r, which is your v square by g, and it is your sine 2 times. It is your pi by 4 minus theta. Okay, angle of projection we have taken, which is less than theta from 45 degree. It is maybe 45 degree minus 5 degree, 45 degree minus 10 degree. So for that, if you consider, it is your v square by g in sine, it is now pi by 2 minus theta, minus 2 theta. So what you will get here, v square by g, it is cos 2 theta. This is suppose first, and this is for r. Suppose we take r dash as the range when it is thrown at an angle which is more than 45 by amount theta. So in this case, it is your v square by g, it is sine 2 times pi by 4 plus theta. That means if earlier it was 45 degree minus 5 degree, means we have decreased the angle by 5 degree from 45 degree at an angle which you are increasing there by same amount. That means 45 plus 5 degree. So at 50 degree as well as 45, we are checking that. Again, you will get the same thing, that it will be complementary there. But that is the another way in which the question is presented, and where you have to prove that one, that it is the same horizontal range. So here, this is your v square by g, it is your sine, again it is your pi by 2 plus 2 theta. And again, sine 90 plus theta is also cos theta. So in that case, this is your v square by g, it is cos 2 theta. This is your second. Now from first and second, if you see that r is equals to r dash. And what are the angles of projection there? In one case, you have got the angle as 45 minus theta. Other case, it is your 45 plus theta. For same velocity of projection, the horizontal range is same. This is the another one which is often asked to either prove it or show it in the given numerical there, or in a particular problem, or in some time it is asked as a conceptual type questions also. Like there are two values of time for same height during the course of motion of a projectile, and the sum of these two times is equal to time of flight. Suppose we take this is the path of the projectile which is thrown with velocity v at an angle theta with the horizontal direction there. Here, for a particular height, if you consider, and this will correspond to two different instants, say it is your t1 and t2. If on the x-axis you have the time, and if you plot the graph, you'll get it like this. So here, what we find that there are two different times for the same height wherever you take. If I take suppose this height, in that case there will be two different instants there. If I take here, then again it will be two different instant of time there. So for same height, there are two different times for the particular projectile in its journey. So how we can get that? Again, we can take help of the equation h equals to ut plus half at square. So using h equals to ut plus half at square. Suppose if I use this one, and that this is suppose the height h. So it will be your h, particular height. Initial vertical velocity is your v sine theta into t. Then it is your minus g into t square. Or if you just write it, you can write it as gt square minus 2v sine theta t plus 2h. This is equals to 0. This is the expression. So here, this is a quadratic equation of time. As it is in quadratic form, obviously there will be two different values there of time. So there will be two solutions for this. Suppose I call it as your t1 and t2. So for same h, there will be two values of time. Maybe in one particular case for given parameters, the t1 and t2 will be equal. That is the case of equal roots there. But in general, as it is a quadratic equation, it will have two solutions. So that will give you the two different times there. By solving this quadratic equation, you can get the time t1 and t2. So if suppose you take that one, how will you get the solution of that? So t there, it will be equals to minus b plus minus b square minus 4ac by 2a. So there, if you consider t, it is minus b. So it is your 2v sine theta plus minus b square. So it is your 2v sine theta whole square minus 4ac. It is your 4 into g into 2h divided by 2a. So it is your 2 into g. So that will give you the two values of time. One case if you take t plus, other case you take t minus. So you will get the two value of time there, t1 and t2. So that way you can show that there are two values of time for same height. And if you now take the sum of that t1 and t2, you will get the time of flight value. But here, if you just go by the problem, and it is saying that there are two values of time for same height. So as you have shown that it is a quadratic equation in terms of h there for time t, So obviously there will be two solutions of t, and you will get the two values of time there. So that can be used to prove that there are two values of time for same height. Second part is there where you have to show that the sum of these two times is equals to time of flight. If I take this one as a quadratic equation, its solutions are t1 and t2. So that means I am going to find t1 plus t2. What are these t1 and t2? These are the roots of this equation. So if I take t1 and t2, that means I am taking the sum of the roots. And if you are taking the sum of the roots, it is how much? It is minus b by a. So this b value is your minus 2v sine theta. So it is your 2v sine theta. A value is g. So it is g. So directly you can show that this time of flight value we can get just by taking the sum of the roots formula. So it is t1 plus t2 giving you 2v sine theta by g, and that is exactly the time of flight. So even if you do not simplify and substitute to get the sum there, you can directly take as the sum of the roots as giving you the value 2v sine theta by g. So this is all there in the discussion of the projectile and its different cases there in its conceptual type questions and different way in which the questions are framed on projectile motions.